Okay, power reducing formula. What we want to do is we want to take something like sine squared of x and cosine squared of x and change them so that we no longer have a squared. Now, the way we do this is we actually use the double angle formula. So one of our double angle formulas using cosine is this. Right? So what we're going to do is we're going to take that, we're going to solve that for cosine squared of x, and that gives us the power reducing formula for cosine squared of x. So if I take this, I add 1 to the other side. And there's your formula. So in order to get rid of the power, you have to get a 2 inside of your cosine. It's trade-off. You can either get rid of the double angle or you can get rid of the power. It depends on what your goal is. We can do the same thing with sine. We also had this formula. So if I take that and rearrange that, now what I'm going to do is I'm going to rearrange that a little bit because I don't want to divide by a negative. So instead I'm going to change it to look like this. But I wanted to show you where they come from. That way you can memorize your you still have your double angle formulas, and you can just rearrange them if you need your power reducing formulas.
So tell me, Mr. Black, what did you do with at least in cosine 2 of x equals 2 cosine squared of x minus 1? Like, why did you do that?
Which one? Which one?
Cosine 2 of x equals 2 cosine squared of x minus 1. How did you know how to set it up?
This?
Yeah.
This is your double angle formula from before break. So we had a double angle formula for cosine 2 of x. That was this.
Okay.
Then we just rearrange it. Yes. Cosine squared. So for double angle formula for cosine 2 of x, we had 3 formulas. We had cosine 2 of x equals this, we had cosine 2 of x equals this, and we had cosine 2 of x equals this. And then our other double angle formula was sine 2 of x equals 2 sine of x cosine of x. Those were our double angle formulas. We don't need these in order to do what we were doing today. So if you remember your double angle formulas, you can use them to get your power reducing formulas if you need them. Now, in the book, there's several other formulas in this section. Sorry, I put away my book. So just so you know that they exist and that they're there, but I'm not making you remember them, and we're not using them at all. But again, just so that you know that they're there. I think I named this 5-4. This is actually 5-5. Sorry. This is 5-5B. There are also half angle formulas. There's your half angle formula. So if you have a half angle inside there, you can change it like this. You have product to sum, so if you have multiplication, you can change it to addition or subtraction. And you have sum to product formulas. I think that's it. But we're not going to use those. We have plenty with what we have. All right. How we're going to be using these is, again, basically your same type of problems. However, your book, the only type of problems they had with these are problems like this, where they give you just something like this and ask you to reduce the power until none of your trig functions have a power on them. So I'm going to go through one with you, and then that'll be it. So I'm just giving you this because, again, this is the only practice in the book that you have to use these formulas. So what it wants you to do is take this and reduce it to the point where you have no powers. Well, to start with, we don't have anything for a fourth power, so I'm going to have to split this up into squareds. Now, to make it a little bit easier, instead of dividing by 2, I pulled it out and put it as a 1/2 in front. Are you okay with that? So dividing by 2 is the same thing as multiplying by 1/2. Yeah, so I just use the sine formula. So sine squared is equal to 1 minus cosine 2x divided by 2. It's just, again, instead of dividing by 2, I just pulled the 2 out and made it times 1/2. That way I can take those 1/2s, and instead of dealing with a whole bunch of fractions, I can just multiply them together and have a 1/4 out in front. Because what I have to do is, I actually still have powers, even though it doesn't look like it at this point. But I have to multiply this together. So I need to FOIL that. So 1 times 1. And then whenever I do this, I'll get minus 2 cosine 2x plus cosine squared 2x. Okay, all of that is fine because none of that has powers on it. Again, my entire goal is just to get rid of any powers. So the cosine 2x, or cosine squared 2x, I need to use the power reducing on that again. Okay, now this time, each time I use the power reducing, I take the inside times 2. Now, since there was already a 2 there, what's the inside now? 4. Mm-hmm. Since I have a 1/2 and a 1/2, I just multiply those two together and put it out in front. For this, yeah, every time I use power reducing, I multiply the angle inside times 2. Again, instead of making this into a fraction, I can just put a 1/2 in front. So with each of these, instead of having this written as a fraction, I could always do this. Yeah. It's kind of like, whenever you guys learned your area formulas for triangles. Some teachers write it as 1/2 base times height. Some teachers write it as base times height over 2. It really depends on how you need it or how you want to write it. But it's all the same thing. But each time you use this, you have to make sure to double this angle. So I don't need to use it again, but if I did need to use it again, this would become an 8. And then if I use it again, it'd become a 16. Then if I use it again, it'd become a 32. Every time you use it, you have to double that angle. And then actually, you can simplify however much you want. If you want to leave it like that, you probably could. I don't care. It just says get all the cosines to singles, so you know what they are. There's no more multiplication to be done, so I'll just leave it like that. Trust me, with some of these, as big of a mess as they are, you don't want to do any more simplifying than you have to. The whole point is to practice with the with the formulas, not to get bogged down with your things. So as long as you don't have any cosines or anything like that you have to multiply together, I'm okay with you stopping at that point. It just will. If you're going to go on to calculus, you'll definitely need this in calculus. They're going to give you problems where you're going to have to simplify trig inside your calculus, inside your integrals and that kind of stuff in order to do your calc problems. So short term, that's where you're going to need it. Long term, you're going to have to go into some very specific things if you're ever going to need this. So most of you, if not all of you, will probably never need this long term. Short term, you'll need it for calculus.
So for